Hello, I'm Reche Guanarapai. Our group, we're going to present about the rectifier with adjustable voltage output. So, for our project, we are going to use Proteus 8.3, and this is our schematic diagram. As you can see, okay. So now we're going to use Proteus 8.3 for our project, and we're going to click for the new project, and then we're going to put our project name, which is the rectifier with adjustable voltage output, and then we create a schematic from selected template. Okay, so for PCB layout, we're going to choose default, and the PCB layout usage, we're going to remain the setting. And for the firmware project, there will be no firmware project. Okay, when we open it, it'll come to PCB layout first. So we're not going to do PCB layout first, we're going to do schematic capture. Okay, so to choose our devices, we're going to select the component mode, and we click the P button there to pick the device. For the first device we're going to pick is the diode, the generic diode, and then we're going to choose transformer, which is the simple transformer. So for our schematic diagram, we're going to ignore first either either the component have PCB layout or not, because we want to review overall schematic diagram for our project. And for this transformer also, we're going to remove afterwards. So for capacitor, we're going to choose the animated capacitor model. After that, we're going to choose our adjustable output voltage regulator. We're going to search LM317L. After that, we're going to pick our potentiometer, and for resistor we are going to use 240 ohm, and we're going to choose the one with PCB layout, so it make easier for us to collect all the components that have PCB first. And then we're going to place all the components in our diagram, and our source, we're going to use AC voltage source, and we're going to search the V sign. So we're going to adjust the whole schematic to center. Okay, we're going to connect all the wires here. So our schematic is done. So we're going to move on to our PCB layout. So we're going to replace the source with the connector. So the connector we are going to use for our input is, we're going to use the subcategory. We're going to search SIL, and we're going to choose the SIL, the the third one, because it has 3 slots. And then we're going to place the connector for our input, and for the output we're going to choose the connector with 2 slots, which is SIL2. So our schematic is done for now for PCB layout. Thank you.
So, hi, I am Cindy. Today, I'm going to explain about PCB layout. So, we can see that there are some of the components have red crosses beside. So, we go back to schematic capture to see what happened. So, we can check the component that don't have PCB footprint. So, in our case, we have red crosses beside the capacitor C1, C2 and C3. So we need to replace the capacitor. From the diagram, we have a 2200 microfarad capacitor for C1 capacitor. So we need to pick the 2200 microfarad capacitor that have PCB footprint. We replace the previous capacitor to the one we chose just now. So we check the C1 capacitor in PCB layout. We can see there has no more red crosses beside it. So we need to do the same thing for the component which have red crosses beside it. So C2 and C3 still have red crosses, so we need to do the same step for C2 and also C3. So after we replace the C2 and C3 capacitor, we need to check again in PCB layout. From here we can see that we left only one more red crosses for RV1, which is our potential resistor. So we do the same step for that also. After this, we can now start our PCB design. After we make sure every component have its own PCB footprint. So to start the PCB design, we need to go back to PCB layout and then do the board for the circuit. Choose the line to board edge. First, for that we need to click the rectangle symbol. Then choose the line to board edge. Construct the board with suitable size. In this case, 6 boxes will be enough. After construct the board edge line, edit the properties. Right click the line and then unclick the box of follow global. Adjust the width to 15. After this, we place the component in the board. So we can use auto placer. Click the auto placer and make sure we select all the components. After this, we need to arrange the component. Make sure there are spaces between components, at least 2 boxes. We need to make sure also they have spaces between components and the board edge, at least 2 boxes. So before we do the root for PCB design, check there if any error using DRM, which is our design rule manager. We can find that in our last symbol in toolbar. Go to net classes, change the top copper to bottom copper in pair one horizontal line. After that, we need to do the auto router. First, we need to go to tools and find auto router and then begin routing. So we can see that they have red root and also blue root. The red root means maybe they are root which crossing each other or maybe crossing the components. So we need to change the red root to blue root by rearranging the components and reconnecting the root. So now we are finished with our PCB design. To see our 3D project, we need to select 3D visualizer. Okay, So now this is our 3D project, which is rectifier with adjustable voltage output. So that's all. Thank you.